Hello children, we are doing class 10 mathematics basic CBSE sum paper 2022-23 section C, 3 marks each. Question number 26, prove that root 5 is a rational number. So we'll write you want to prove that root 5 is a rational number. So we'll assume its opposite at first. So in the answer what we'll write, let root 5 be a rational number. Again, let root 5 equal to a by b. Let root 5 equal to a by b, where a and b are coprime integers. Coprime integers means HCF will be 1. So where a and b are coprime integers. And denominator b not equal to 0. I will cross multiply. So root 5b equal to a. I will square both the sides, squaring both sides. So root 5b the whole squared equal to a squared. Root 5 into root 5 is 5. B into b is b squared equal to a squared. Now if we'll divide both sides by 5, we'll write here, actually separately I'll write 5b squared equal to a squared. When you'll take this 5 to the other side or divide both sides by 5. 5b squared by 5 equal to 5a squared by 5. So you can see that on. Now 5 came under a squared. So we'll say that 5 divides a squared. So here 5b squared equal to a squared we did. And just for getting the sentence, for those who are finding difficulty, you can get the sentence in this way. This 5 is below a squared it is. So we'll write 5 divides a squared. If 5 divides a squared, then 5 divides a. It is based on the theorem, if a is a prime number, using theorem, if a is a prime number, like p is a prime number and p divides a squared, p is a prime number and p divides a squared, then p divides a also. Instead of p here it is 5. And p divides a is the property. So here if 5 divides a squared, then 5 divides a also. Where a is a positive integer. Where a is a positive integer. Now here p is, 5 is replaced by p actually, or p will be replaced by 5. Now if 5 divides a, so we'll write 5 divides a. So a by 5. We'll assume that one as c. So from there we'll get a equal to 5c. So now we are assuming that a equal to 5c for some integer c. Now here we'll write let a equal to 5c. From where we got means Here 5 divides A, we wrote 5 divides A. A by 5 equal to C. So we'll assume let A equal to 5C. Equation number, here this one I'll name as 2. This one as 3. For some integer C. Now substitute 3 in equation number 1 was that. Substitute 3 in 1. So it will be 5b squared equal to, once more I am just writing that on, later no need. 5b squared equal to a squared, that was 1. In that one we are substituting, that was 1 actually. In that one we are substituting equation number 3. So 5b squared equal to, instead of a we can write 5c the whole squared. So that is 5b squared equal to 25c squared. When you will divide throughout by 5 or cancel directly 5 when you take the other side, it will go to denominator. So b squared equal to 5c squared. So I'll just show that division. 25c squared by 5. So it will be b squared equal to 5c squared. Now again you are dividing both the sides by, that one separately we will write. We are dividing both sides by 5. When you divide both sides by 5, it will become b squared by 5 equal to 5c squared by 5. Or directly you can take 5 to the other side. So now 5 and 5 will be cancelled. Now here you will get now here b squared by 5 equal to c squared. Now 5 is below b squared. So we'll write 5 divides b squared. If 5 is dividing b squared, then 5 divides, therefore 5 divides b. I'll name it as equation number 4. Again it is based on the theorem only, using theorem. If P is a prime number, and if P divides a squared, because in the theorem it was in terms of a squared, so that is we are writing a squared. Actually here it is b squared, p is 5. Now a squared, then p divides a, where a is a positive integer. Here actually instead of p we used 5, and instead of a squared now we wrote b squared. At only a squared we wrote b squared. Now here 5 divides a and 5 divides a and 5 divides b. So 5 is dividing both a and b. So that means 5 is the common factor of both a and b. So now thus 5 is the common factor of a and b. How? Because in this one equation number 2 5 divides a, equation number 4 5 divides b. So 5 is dividing both a and b means 5 is present in both a and b. That means thus 5 is the common factor of both a and b from equation number 2 and 4. But this contradicts the fact that a and b are coprime integers. What is the meaning of coprime integers? HCF is 1. Common factor is only 1. So, thus our assumption is wrong. Therefore, root 5 is an irrational number.